Hi guys, so today we're going to start section 4.3, which is right triangle trigonometry, which is related a lot to what you thought trig was last year in geometry. So given a right triangle and your angle theta right here, the three sides of the triangle, hypotenuse is always the length, side length opposite your right angle, so the biggest side. The adjacent side is the side connecting the angle you are talking about with the right angle, and the opposite side is the remaining one. So last year you learned about SOHCAHTOA. If you forget what those stand for, here are the three that you learned last year: sine, cosine, and tangent of the angle we were dealing with, bottom left here. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then we learned about our three new trig functions, which are the reciprocal functions: cosecant, secant, and cotangent, these guys here. So hit pause, take a few minutes, and write down those 6 equations. Note, if you need to, OPP is opposite side, ADJ is adjacent side, and HYP is the hypotenuse. Okay, so let's talk about it here. So once you have two sides of a right triangle, you can find the third one using the Pythagorean theorem: a squared plus b squared equals c squared. A and B are just the legs. Make sure that you keep them separate. So I'm going to say A is 3 and B is 4. So in this case, 3 squared plus 4 squared equals our hypotenuse squared. So 9 plus 16, 25 is c squared. So c will equal 5. When we get into plotting these points on the coordinate plane, your side lengths could be negative depending on what quadrant you're in, but the hypotenuse is always positive, always positive. So our hypotenuse is 5 here, so fill that into the triangle and come back up here. They identified what theta is. Theta is the angle down here on the left. So the sign is opposite over hypotenuse. So in this case, opposite, the one not touching it. So 4 over the hypotenuse we just found is 5. What would cosine be? Cosine of theta is adjacent, which is 3 over the hypotenuse. And then tangent is opposite over adjacent, which is 4/3. Or tangent is also sine divided by cosine, so you could have divided 4/5 by 3/5, flip this guy over, and that's where you would have gotten 4/3. The reciprocal functions, cosecant, just look at sine and do 5 over 4, or the formula here was hypotenuse over opposite. I always found it easier just to memorize these 3 here on the left and just do the reciprocal. So secant is going to be 5/3 and cotangent is 3/4. Will your side lengths always be integers? The answer is no. Sometimes your hypotenuse might be something crazy like the square root of 21, and you might have to rationalize your denominators for any of the 6 trig functions if there's a square root on the bottom. So just remember that square root rules apply. So if this, instead of being 5, would say the square root of 10, your sign would be 4 over root 10, then you just need to rationalize and have it be 4 root 10 over 10, and then you could simplify. All right, we'll do more of them in class next time. Let's see. All right, these here, the fundamental trigonometry identities, it looks like a lot. However, take it slow. Reciprocal identities. The top 6 here are just telling us exactly what we've been doing with our chart, with sine, cosine, and tangent being one on top of each other, and then cosecant, secant, and cotangent being the reciprocals of sine, cosine, and tangent. These two here, the quotient identities, what I said earlier, Tangent is y over x, or opposite over adjacent, or just take sine divided by cosine to get tangent. And then since cotangent is a reciprocal of tangent, it would be cosine over sine. And then these three new identities called the Pythagorean identities. Sine squared plus cosine squared equals 1. In order to get the other two from sine squared plus cosine squared equals 1, if you ever forget the other two. So sine squared plus cosine squared equals 1. Yes, I'm being lazy and not putting the angles just for this demonstration. If you divide all three of these by sine squared, that cancels, that equals 1. Cosine over sine. Let's go back over here. Cosine over sine is cotangent, so this is cotangent squared, and this should be a plus, not equals to. And 1 over sine. The reciprocal identity of 1 over sine is cosecant. So cosecant squared of theta. Put thetas in all of these. That is the third one. So you can always divide the whole equation by sine squared. All right? Hit pause if you need to look at that again. I know I went quickly, just for the sake of your time. All right, and instead of dividing everything by sine squared, let's divide it by cosine squared. So cosine squared, cosine squared, cosine squared. This sine squared over cosine squared would be tan squared plus 1 equals secant squared. That is the second Pythagorean identity. Hit pause if you need to for that one. So as long as you have the top one memorized, the sine squared plus cosine squared equals 1, you can obtain the other two by dividing the entire equation by either sine squared or cosine squared. Hit pause if you haven't written down these 6, 7, 8, 9, 10, 11 identities. You will need to memorize these and be able to utilize them when solving any type of trig problem. All right, so let's apply one of them. So let theta be an acute angle. So that means we're going to be in quadrant 1, such that cosine of theta is 0.8, so 8/10. Find the values of sine and tan using the identities. So looking back at the identities, we have cosine right now, and we want sine and tangent. So looking at cosine, out of all of these, we can cancel any ones that don't have cosine at all. And then we want to find sine and tangent. So these two don't have anything to do with sine and tangent, so let's get those ones away. This one has sine, cosine, and tangent in it, but we only have cosine right now, so that's not going to help us entirely. However, this one here has only sine and cosine, so let's use that identity to help us solve for theta, or sorry, solve that one for sine of theta. So sine squared theta plus cosine squared theta equals 1. That is the Pythagorean identity. Let's plug in 0.8 for cosine, so 0.8 squared, because it was cosine squared. The squared goes in front of the theta so that someone doesn't think that the angle is being squared, but that means the same thing as cosine of theta, whole thing in parentheses, squared. Plus sine squared theta equals 1. All right, 0.8 squared is 0.64 plus sine squared theta. Subtract 0.64, so sine squared theta equals 0.36. Square root both sides, and you get sine of theta to be 0.6. So that would be what sine is. Let's see if I can make some room here. All right, so now we have cosine and sine. So let's go back to our identities and see, all right, which one we're going to use for tan. Well, this one here that I'm going to circle in purple has sine and cosine to help us with tan. So tan is sine divided by cosine. So tangent of theta equals sine theta over cosine theta. Let's fill in what we have. So sine is 0.6, cosine is 0.8. Dividing that out, tangent will be 0.75. So that is the value of tan of theta. So we just found sine theta and tangent of theta based on the identities. All right, that is all I have for you guys today. Your homework will be dealing with this stuff and what we dealt with in class yesterday. Let me know if you guys have any questions. I hope you guys have a great day. Thanks.